Hey, what's up everyone? Welcome back to the channel. In today's quick sensor tutorial, I'll be showing you how to use the HCSR501 passive infrared sensor with the Raspberry Pi Pico or Pico W and MicroPython. By the end of it, we will have an example as shown here, where we'll be pairing it in conjunction with an LED that will trigger this LED based on detection of the sensor of your hand. So this sensor, as you know or you do not know, actually detects infrared radiation from somebody, so humans and also animals, emits infrared radiation. So this sensor is good for applications where you want to detect some moving body. So this can be used for a garage door and of course various other applications. Really interesting sensor and incredibly easy to set up using MicroPython and the Raspberry Pi Pico W. I'll be showing you the physical setup and the code setup, so we'll learn end to end how to incorporate this into our projects. Enough being said, guys, I do not want to waste any of your time. Let's jump into it so I could show you the physical setup followed by the code we need to get this thing working. Okay, so jumping to the physical connection diagram really quick, I am using a breadboard, and of course you want to have a set of jumper wires. And these are the connections we're making, pretty straightforward. So we just take 3 jumper wires from the HCSR501, black and ground to the ground pin on the Pico W, red is the power pin for the HCSR501, and we're just connecting that to the 3.3 volt pin on the Pico W. And now, unfortunately, the sensor does operate at 5 volts, and the Pico W only outputs 3.3 volts. However, from what I'm seeing in practice and from what I'm reading online, this sensor can operate pretty reliably at 3.3 volts, which is all we have to work with this device. So it's fine if we just go ahead and connect it to that 3.3 volts pin on the Pico W. And in the middle there, we have the signal pin. So this is this is a digital output signal. So if it's 1, that means we detected an infrared detection, and if it's 0, that means we are not detecting anything. And I'm just connecting that to the first GPIO pin on the Pico. Next, we have this LED, so the ground pin of the LED, which is the shorter leg of the LED, is the ground leg. We just connect that to the same ground as the HCSR501, and then we have the longer leg here, which is connected to any GPIO pin you want in conjunction with the resistor. This resistor is just for current spikes, so it's good to use a resistor for LEDs because it can prevent them from burning out. And we are just connecting it to that 4th pin there, which is a GPIO pin. So that's all we have in terms of the physical connection. Now go ahead and of course plug this in at that point, and you should have everything from the jumper wires and all the connections you need to actually get this thing to trigger on. Okay, so another thing I quickly want to make note of is that this device has 2 potentiometers that are pretty important, and I'll just briefly explain what they are. So on the left, we have the time delay potentiometer. This potentiometer dictates the amount of time it takes for the signal to reset after it has been triggered by a high or an infrared detection. So what I mean by that is if my hand moves in front of this sensor and it detects something and it goes on a high, it has to wait for the certain time delay to go back to 0 and say it's not detecting anything. So the more we move this counterclockwise, the faster it'll go back to 0 and say it's not detecting anything anymore. I just moved it all the way counterclockwise, so that is the fastest time delay reset. So that's typically good for us because it'll allow us to keep trying and triggering it quickly because it'll reset quickly and it'll allow us just to experiment faster. And some other cases, you maybe want it to reset after a few minutes, and I believe the maximum is, I think, 5 to 10 minutes. I will put that more in the description. I'm not sure exactly what the specs are, but this thing can take a long time to time delay if you would like it to. On the right there, we have the sensitivity potentiometer. So I just put that in the middle. This just dictates the distance of the infrared signal it can detect. So the maximum I believe it can detect is about 7 meters. Once again, I'll put the specs down below. So we're just putting it in the middle there. So I believe that's maybe a few meters of detection, so it can detect a hand from a few meters away. You can go ahead and play around with this for yourself, but the middle is fine for experimentation purposes. Of course, you can adjust this as you need for your applications. Finally, the last thing I want to explain, which is a little more complicated, and we're not going to go into too much detail about because it's a little more complicated for beginners especially, is this position 1 and 2 here for this pin. Now for our experiment today, we're just putting this yellow pin on position 1, which is in the front there. And position 1 just means we do not want repeat triggering. And position 2 means we will allow repeat triggering. So I'll try to briefly explain it in this diagram here. So on the left here, what we have is how the sensor would behave if we left that pin on position 1. So if we left it on position 1, what would happen is if we detected a motion, the sensor would eventually come to, first it would start at 1 once it detects that infrared detection. And then after the time delay that we set, it would eventually go back to 0. And then in this period, once again, it could eventually detect a signal again, but you'd have to wait for the time delay to elapse. In the second case, what could happen is if we do detect a signal, this is in the repeat triggering case, if the position is in pin 2, so if we do detect a signal, it does go to 1, and we see the time is moving forward. If we detect another signal within that time period, the signal can actually remain high. So hypothetically, this sensor can remain high as long as it's continually detecting an infrared motion in front of the sensor. So this can be useful for other applications where you want to maybe hold the LED in, keep it on as something is continuously moving in front of the device, or other applications where you want repeat triggering. So I hope I did my best to explain that. We're going to use position 1 today, which is just for single triggering. Otherwise, if you want to have an application where you want to continuously detect a signal no matter what, you can move it to position 2. And I'll link you down to my blog below, which explains this in a little clearer detail and wording on my Shield Tech blog. So I hope you guys read that if you're confused. Now let's jump into the code side of things to show you what's going on there. And finally, once that's done, we should be able to get it all together and trigger this LED with our hand. Okay, so jumping into the MicroPython code, which is the last step. Of course, you want to have your device connected and have MicroPython installed. I'm using the Thani IDE to code on my Raspberry Pi Pico W. Very simple code, so we're just using the machine library to connect to the respective pins. That is the PIR and the LED, and we're using the time library for some time-related operations. So we're just setting the PIR state that is false, so we're just assuming no motion is detected at the beginning. And we're creating something called a debounce period. Now this is very important. What I noticed with this device when we're using it with Pico W is that whenever we trigger a signal, sometimes what happens is it re-triggers another signal after it detects a hand or some infrared radiation in front of it. And I believe this is a false triggering of the device, maybe because we're using it at 3.3 volts, or perhaps some of these sensors are a lot more finicky than I imagined. But it's good to have a debounce period that is a cooldown period that allows us to say, during this period, do not trigger anything regarding the LED, because we do not want any false signals inflowing into our application to do anything. So I just defined something called a debounce time. You can go around and play with this period. I found that 3 seconds is typically a safe period for our application. And this is just to keep the sensor from false triggering and falsely triggering our LED without a infrared signal. Just something I noticed there. And then we just initialize the module. Now, from what I'm reading online, this sensor typically has a larger initialization time than needed. So I think 1 second is not enough. Maybe you want to wait like 20 seconds or even a minute, from what I'm reading online. So even up to a minute could be good to allow this thing to calibrate properly when you first turn it on. And then simply in this while loop, what we're doing is we are just finding the value. So this is just the digital output of the sensor. So that is 1 or 0. And then we're measuring the time. So this is the time we're measuring. And that is just for resetting the debounce time. And then we're just printing this value. So if you print in Thani and you open the plotter, it'll just print the values of the sensor. So that's just good to see the behavior. And it'll allow you to determine what I'm talking about. So you will see those false triggerings on the HC SR501 with the Pico W at times, which is kind of weird. And the next thing we do is if the value is equal to 1 and we don't have a previous state, what we're going to say is we actually did detect something new. So we will turn the LED on and we will start the debounce period of 3 seconds. Within that period, nothing should happen and the LED should remain on until the debounce period is off. Only then can we re-trigger the LED. Otherwise, if the value is 0, what we're going to say is if the state was true, that is if we had a signal from before, we are going to turn the LED off now, and we're going to update the last motion timestamp. So this is in regards to the debounce period. And that's pretty much all we are doing here. So very simple code. Pretty much the gist of it is we are just trying to turn on the LED if we detect a signal. Otherwise, we are going to turn off the LED, and that is pretty much all we're doing. So I have my sensor pointed away from me, so I hope it doesn't trigger. This thing uses a very special lens called a Fresnel lens, so it can detect infrared radiation from like really weird angles. So typically almost a 180 or 360 degree around the sensor in the direction it's pointed at. So you want to keep that in mind. It is a lot more sensitive than you think. So we're going to go ahead and run this code. And I'm actually going to point to my setup here as I'm running this code to show you if it's working as expected. So let's go ahead and run this. You can see I am not in the way of the infrared sensor at all. So it's pointed away from my body. I am the infrared radiation. And so you see nothing is happening. So if I go ahead and move my hand in front of the sensor, it will trigger that LED. Okay, so that is pretty cool. And so that's pretty much it. You see that it did have a second false reading there, but thankfully to the debounce period, it did not trigger the LED again. One more time, we're just going to move my hand in front of it and it should trigger the LED, and that should be it. So go ahead, move my hand in front of it. So I hope you guys see. And yeah, that is pretty much it, guys. That's all the setup we have today. We triggered an LED with a motion detection sensor, a PIR sensor specifically. Pretty simple to do. I hope you guys learned a lot. If you did, please be sure to like, comment, and subscribe to the channel. Let me know if you're having any issues in the comment section as well. I know this sensor is a little finicky with the Pico W, so let me know if you're having issues with it. Please be sure to like, comment, subscribe, and I will see you guys in the next tutorial.